Hello all, hope you're all doing great at home, and I really hope that the quarantine is not going bad with anybody. Nobody is tired or frustrated. You have everything under control. I know it's a weird situation for everybody, but as long as we are all healthy and safe, I think we are doing great. I want to thank you for your patience about learning online and not having, like our lectures in class. I do miss you all, and I wish, like after this quarantine ends, after all of these ends, we can still, like see each other on campus and learn more together. Okay, so this video that I'm preparing, it goes along with chapter 15. I'm gonna go over the concept of instrumental variable and two-stage least square. And then in the next video, I try to keep this video as short as 15 minutes, and in the next video I'm gonna go over the RDD and SE, which like I will tell you in the next video what are those about. Okay, I think this is enough intro. We can jump into learning what is instrumental variable and what is a two-stage least square technique. Okay, so instrumental variable is often used when we are facing the problem of endogeneity in the regression. Okay. Endogeneity occurs in the regression. We talked about it before in earlier lectures, that endogeneity is a problem that when we have omitted variable bias, or we have measurement error in the regression, or I think those are the main two reasons that endogeneity occurs. Okay, so and we have different solutions to solve for the problem of endogeneity. We can use proxy variables. Okay, we can use fixed effect. We said that like there is a lot of advantage for us to use panel data because in panel data, if we are thinking that the regression may suffer from endogeneity problem, we can incorporate fixed effects. We can incorporate time fixed effect, individual fixed effect. If we have if we are regressing country level variables, we can use country fixed effect. Okay, so we already talked about different solutions to endogeneity. Again, like one of them is fixed effect, the other one is using proxy variables. I think you all are familiar with proxy variables. It's not a very advanced concept in econometrics. Proxy variables are mainly used, for example, like one of the famous example of it is using GDP as a proxy for quality of life or a standard of living in country level studies. Okay, so we don't have exact measurements of people's quality of life, right? But we can use GDP per capita as a general indicator of quality of life for a specific country. Okay, so that's called proxy variable. And you are all familiar with the fixed effect model. So today we are going over instrumental variable. It's kind of, I think, like the idea is kind of similar to proxy variable, but the difference is that we do the IV method in two stage. That's why we call it instrumental variable and two-stage least square, because first you use that instrumental variable to regress one of your independent variables, and then you use that estimated independent variables in the second regression to estimate your y variable. Okay, so it's kind of like two regression, or it's like two stage. Okay, in the next slides you will see examples of that. So I'm currently going over the first slide again on the chapter material of Wooldridge chapter 15, the PowerPoint presentation. Okay, so if you can all open that PowerPoint presentation, you see on the first slide that it goes over proxy variable and fixed effect, and then it introduces the instrumental variable method to solve the endogeneity problem. Okay, so let's go to slide 3. Okay, slide 3 goes over an example of instrumental variable. So the example, in this example, it's a very common example. Again, we are regressing wage rate on education, or we want to see like how much education affects people's wage rate, right? If you just run wage rate or log of wage as it's indicated here on education, definitely, you know, like you're suffering from a lot of problem in this regression. You're suffering from omitted variable bias for sure. So one way or another, education would be overestimated or underestimated in this regression, because you know that it's not a very good regression. You need to include a lot of other variables. You need to include IQ, you need to include age, you know, like we talked about that regression before. So it's missing a lot of variables. Okay, but let's use the IV method to correct for this endogeneity in this regression. Okay, instrumental variable need to have 3 conditions. Okay, it does not appear in the regression. Okay, it shouldn't be one of our independent variables. It should be highly correlated with the endogenous variable. Okay, and it should be uncorrelated with the error term. Let me jump into the example so you understand it better. I'm gonna skip next slide because it goes over the proof of consistency when using IV. You don't need this proof. You don't need to know this proof in detail for the purpose of this class. And next slide, so I'm skipping also slide 5 because it also goes over the mathematical proof of the consistency of instrumental variable, but in slide 6, that's where we have the example. Okay, so in this example we are using father's education as an instrument for education in the wage regression. Okay, first we set up, so if you see like the first equation regresses log of wage over education, and the coefficient of this regression is 0.109. It's pretty high, so it's we expect that, or we think that it's overestimating the effect of education on wage. Okay, so in the second equation shown in this slide, we have education, and we have father's education as an independent variable to explain education. So first we regress education on father's education. We calculate the estimated education. Okay, and then we use that estimate in the third regression in this slide to calculate the unbiased coefficient of education. So as you see that this second coefficient is 0.059, which is lower than 0.109. Okay, so we think that we corrected for some of the overestimation of education here. Okay, and the standard error is also higher. Okay, so the variable is less significant than the original equation that was suffering from bias or from endogeneity problem. Okay. Father's education is a famous IV or famous instrumental variable to correct for the endogeneity of education in the wage equation. Okay, so why you think that why you think that education was overestimated in wage? Right, there are several reasons or justifications that why it's overestimated. One of them is that like part of wage, part of one individual's wage is high not only because of his or her education, but also because of his or her IQ, right? And we're not including IQ here, so education is absorbing all that effect, but it was really like education and IQ and social skills and other factors which are omitted from that regression. So basically we are trying to correct for that problem. Okay. In the next slide, slide 7, you have other examples of IV in the education regression. You have number of siblings, you have college proximity when 16 years old, or any other age can be used. Specifically in this literature, college proximity when 16 years old was used, and also month of birth. So I want you to meditate on these three variables for a few minutes and think about, if they meet the requirements of IV, and also if they are a good IV in your opinion or bad instrumental variable. For example, to me, month of birth is not a very strong instrumental variable in this regression. Okay, but that's my opinion. We also have checks that we introduce in the next slide to measure how weak is the IV or how strong it is, how appropriate it is to use this IV in our regression. Okay, so in the next slide, slide 8, the slide goes over properties of IV with a poor instrumental variable. So you have to calculate the correlation between instrumental variable and error term, and instrumental variable and the independent variable. Okay, so as you see, it's in the last line of this slide, you have correlation of Z, which is our IV, and U over the correlation of Z and X. If this ratio is greater than the correlation of X and U, you can calculate it. So for example, here it's 0.03 over 0.2, which is greater than 0.1. I'm going over the last line of slide 8. So we say that we have a very weak instrumental variable, so it's better not to use this IV, if those correlations hold. All right. And let me see what is the rest of the slides. In the next slide, slide 9, it goes over the IV estimate in multiple regression. Now you have multiple exogenous variables. and you have one endogenous variable, you can go over this slide by yourself. Similar concepts, you still have to satisfy the 3 conditions, and there is a proof of consistency and properties of these IV in multiple regressions. And probably it would be a good idea if you kind of like meditate on the last 2 lines of slide 11 to you have the first stage, okay, and the second stage of the estimation. Okay, so it kind of like you see here better than that what is the 2-stage least square estimation. All right, and there are also like a slide 13 is important. We have the properties of 2-stage least square, the standard error from the OLS, second stage regression, is important to look at it, okay, because the okay, so let me see. If there is one endogenous variable and one instrument, then the 2 SLS method would be equal to instrumental variable, okay. And the 2 SLS estimation can also be used if there is more than one endogenous variable and at least as many instruments. Okay, so these are like a little bit like getting deeper into these concepts. Okay, and you also want to review slide 15. Okay, so I hope this video would help you a little bit to get more comfortable with reading these slides. I prepared an example of IV which I'm gonna share with you in quiz 4 next week. So I think it would be a good stopping point here. You kind of like got a general idea that what's instrumental variable, what is a 2-stage least square, and you would get a deeper understanding when you do the example. All right, I think that's it for now. I wish you all a great day, and I also wanted to thank you for working on quiz 3 and homework 3. You're all doing great, and I wish you best of luck. So please let me know if you have any questions from this video, from the chapter material, and I try to provide that good example on quiz 4 for you to do more practice on IV. All right, bye guys, have a good day. Bye bye.